In PostgreSQL, every update and every delete leaves a mark. The old row version is not removed from disk. It stays as a dead tuple. Leave them piling up, and your tables bloat, your indexes swell, your queries slow down, and eventually the database can force itself to shut down. The thing that saves you is Vacuum. So let's see what it does, and why it matters. Here's why dead tuples exist. Postgres uses MVCC, multi-version concurrency control. When you update a row, Postgres does not overwrite it. It writes a brand new version, and marks the old one as dead. When you delete a row, it marks that version dead too. Old versions are kept around until no running transaction can possibly still need them. Then, and only then, can they be reclaimed. Let's make this real. We have a 1 million row orders table. On the left, watch the n_dead_tup column in pg_stat_user_tables. Right now it's 0. Now we update 500,000 rows and delete 200,000. That's 700,000 dead tuple versions sitting in the table. Now look at the damage. The table grew from 101 megabytes to 153. Using the PGSTATTUPLE extension, we can see exactly 37% of the table is now dead space. Every sequential scan reads that garbage. Every index carries the bloat. This is what bad vacuum hygiene looks like. On the right is the fix. Vacuum scans the table, finds dead tuples that no transaction can see anymore, and marks their space as reusable. Vacuum Analyze also refreshes the planner's statistics. Watch, we run Vacuum Verbose Analyze on orders. And there it is. n_dead_tup drops from 700,000 to 0. The space is reclaimed for future writes. But you shouldn't have to run this by hand. That's what the auto vacuum daemon is for. It runs vacuum and analyze in the background, per table, automatically. You can see its workers here in pg_stat_activity. So what controls it? Let's check the knobs. Auto vacuum is on. Auto vacuum _scale_factor is 0.2, meaning a table is cleaned once 20% of it, plus the threshold, has changed. Auto vacuum _threshold is 50 changed rows. Auto vacuum _cost_limit and cost_delay throttle vacuuming so it never starves your real queries. And you can override any of these per table with storage parameters. But here is the consequence that keeps database administrators up at night: transaction ID wraparound. Postgres transaction IDs wrap at 2 to the 31st, around 2.1 billion. So every row must eventually be frozen, a permanent marker that it's old enough to be safe. Auto vacuum _freeze_max age, 200 million, controls when auto vacuum starts freezing aggressively. You can watch how close you are with the age function on DAT frozen XID. If freezing ever falls behind, Postgres stops accepting writes and runs a single auto vacuum until it's safe. That is an outage. So, get vacuum right, and Postgres stays fast and never wraps. Get it wrong, and you bloat, you slow down, and you risk downtime. The right settings depend entirely on your workload. Heavy writes, huge tables, append-only data. They each need different tuning. That's the next video. For now, subscribe and vacuum your tables.